Hello everybody, welcome back to your channel Echo Engineering. In this video, we are going to implement a machine learning model in order to predict the market crash for any shares or any indexes, including, for example, S&P 500 or Nasdaq, along with, for example, any cryptocurrencies like Bitcoin or Ethereum. The code can be extended for any shares or any indexes that you would like. This video has two sections. In the first section, we talk about how we implement the code and what is the purpose of this code and this model and how we are going to do it. And in the second section, we go through the code and I show you how I implemented it. If this is your first time watching our channel, in this channel we focus on algorithmic trading and implementing machine learning models to predict some specific behavior of the market in the future. I leave you the link to the most important videos of this channel in the descriptions. You can go through them, and I hope you enjoy this video and stay with me to the end. To predict the market crash, we go through several sections. The first section, it is data engineering. In this section, we will focus on data engineering, which consists of two main steps. Okay, the first step is importing market data. We will import historical data from the S&P 500, Bitcoin, or any other market that we want to predict crash for. We will use the Y-Finance library to pull this data from Yahoo Finance. This data will include market information such as price, volume, and other relevant factors. Then we will add the indicator and market crash criteria. We will add key indicators that might signal a market crash. This could include, for example, factors like volatility, dividends, or even the opening price of the day. These indicators will help us to build a model that predicts whether the market is likely to crash or not. After gathering data, for example, over the last 20 years, we will split them into two different sets. The first one is training data, which is used to train the machine learning model. And the second one is test data, that we use this test data to evaluate the model's performance later on. Then, in the second section, it is called training the machine learning model. We will use the scikit-learn library to train a classification model on the training data. The goal here is for the model to learn the relationship between our chosen indicators and the market crash label. In other words, we want the model to understand what pattern or signals lead to a crash. Then in the third section, which is the testing the model, once the model is trained, we will use the test data to evaluate the performance. This test data includes information that model has not seen before, allowing us to know how well it can predict market crashes. By comparing the predictions to the actual data, we can find out how accurate and reliable our model is. It's very important that the model be tested on a data that it has never seen before. That's why we split the data to train data and test data, and they have nothing in common together because we don't want our model to be tested on the data that it has seen during the training. It would be like not cheating if the model see the data that it has seen before them. So this is why we split them in the completely two different test and training data and completely separated from each other. Then in the fourth section, it is evaluating model performance. In order to find out the performance of our machine learning model on the test data, we use several evaluation metrics, including accuracy score, which it measures how often the model makes correct prediction, then the classification reports, which provide details, metrics like precision, recall, and F1 score, and then confusion metrics, a table that shows the number of true positive, true negative, false positive, and false negative prediction. We will discuss them, what do they mean, and what we can find out from. And then in the last section, it is hyperparameter tuning. In the case that the model did not have an acceptable performance, then we configure the hyperparameter of our model during the training phase or fitting phase or training phase. And by changing these parameters, we train the model again, we test them again, and we perform and evaluate the performance one more time. And we repeat this loop as much as that finally the model would have a good performance on the test data. So it would be train, test, evaluate, tuning hyperparameter, again repeat it by giving it new hyperparameters, tuning them, changing them, configuring them, then test them again. And at the end, when we reach an acceptable model, then it is time to use the model to monitor market 24 hours a day and 7 days a week. It means that we run the model in a logic which is inside a infinite while loop, and it will be repeated every time. This infinite while loop monitor the whole market, and after some, for example, conditions, some logic trigger, then we want to send order or close an order, which in this case we are using the broker API or library to send and close the order. For different brokers have different APIs and different libraries. For example, for Binance, we have, I think, Python Binance, and for Coinbase, we have CB Pro library. There are libraries for Python. We can easily use this library, and we can find the instructions for this library on the internet very easily, and they are very useful. So in the next section, we go through the code and I show you how I program this model and how precise this model can perform. See you in the next section. Okay, in this section, we are going to program our model. We are using Jupyter Notebook to implement our code. But before going through the code, if you are not familiar with machine learning models, in the video that I explained it, you can find it, and it's better to go and watch it. I'll leave you the link here, and you will find out what's different between the classification model and regression model. In this video, we are using the classification. So please go watch it. It's important. In the first cell, I don't run it. We just learn how to install the libraries that we are using here. You should just write pip install yfinance, scikit-learn, pandas, numpy, matplotlib. We are using this library in this programming code, so you should install them and press shift and enter to install them. I don't press shift and enter because I already installed them. Then we add our library and we import them to use them in our code. The first one, import yfinance as yf to pull the data from Yahoo Finance, and then import pandas as PD to work with the data frame, and then import pandas TA as TA to use with the technical indicators and using the indicators of technical analysis. In order to do so, we use pandas TA. Then we import numpy as MP. We may not use it, but normally numpy is used for numeric calculations. And now we go to the scikit-learn machine learning library. From this scikit-learn, first from scikit-learn that model selection, we import train test split method. We use it to split the data to test and train. Then from scikit-learn ensemble, we import random forest classifier. This is the model that we are gonna work. We have regression 2 for predicting the price, but in this case, because we only predict a true and false, whether the market crash or not, it's a true false classification. Then we are using the classification model because we want to predict only a true and false. Then from scikit-learn metric, we import accuracy score, classifier report, and confusion metrics. These are the criteria we are using to evaluate our model, and we are using them only for classification model. For regression model, we use different criteria here because the model is classification. We use these criteria, and then we import matplotlib.pyplot as PLT to plot. And then from date and time, we import time delta because it's useful, and we wanna do the calculation for some date time objects. I press shift and enter. Now it is run without any error. In the next cell, I define two strings. The first string is start date, and it is from the beginning of 2010, and the end date is a string again, and it is until the beginning of 2023. Then I use the yfinance yf.ticker. In parentheses, I add the ticker of S&P 500, which is written like that, and I add it to a variable named start.data, and then by using stack.data object and dot history and give the start and end date as a property to this history, I would have access to the data of S&P 500. I press Shift and Enter, and I read this S&P 500 database. I can see that it is the database of this data frame of this S&P 500. Open, high, low, close, volume, dividend, and stock split. All of them are written here because S&P 500 is an index. Normally the dividend and stock split are zero. We don't have dividend and stock split. But if it was, for example, an Apple share or a Tesla, we would have dividend and stock split too. And here I just add another variable. Actually, I want it to be today date. I want it to be date and time format object. So I just say from date time object import date time, and here today is equal to date is date time. I should run it again. Date time dot today. This one returns as today object, and I just want it to be the date. I want to see the date of today. Okay. I press Shift and Enter again. We have the S&P 500 here, and I want to see that today. I can see that today is 14/9/2024, and it's a date time object. So I just delete it too, and we go to the next step. Now we have our S&P 500 data frame. See, it was very easy to get the data of the S&P 500, but instead of using it and hard code it, I prefer to define a function for it. So here I press Ctrl V. I already wrote 3 functions to do 3 different tasks, and actually 4 functions to do 4 different tasks. And instead of just adding the getting the data for S&P 500, I use this get stack data function to get the data for any kind of index or cryptocurrencies or shares. So from now on, instead of hard coding it, we use this function. We have 4 functions here. The first one is get stack data, and then it get the ticker, start date, end date, and it used the same procedures that we had here to add a stack with Y Finance and define and get the data frame and return the data frame. At the end, it returns the data frame that very similar to what we had here. We can see it. It would be a data frame like that. So I just ignore it. And then another function, which it add the technical indicator, def add technical indicator. It take a data frame like the data frame, but the same format that we had here, and it uses the TA or Pandas technical analysis to add single moving average 50, single moving average 200, RSI 14, and volatility like that. I will leave you the link to the video that I explained the Pandas TA here. If you don't know how it works, you can go and see it. But this volatility, just the volatility is important to know. It says take the close column and calculate the standard deviation for the last 30 days. And then it delete all the rows that there are some NaN. It means when we have a rows without the data, it will be deleted, and in place is true, so these changes would be permanent on the data. And then we return our data frame. And then we have another function named label crashes. It takes a data frame and a threshold. For example, here we can say 0003 minus, and this threshold means when the price changes today in comparison with the previous day is below this, then we consider it as a crash day. Okay, so we define this logic here. We say add a crash column and use numpy var method, and it says whenever the percentage changes of the close for today is below this threshold, consider it as a true or 1, and when it is not below, consider it as 0 or false. Just because in the data modeling, instead of true and false, we want it to be 1 and 0, so we work with numbers. It's easier. That's why we use 0 and 1, not true and false. And here is the last function. We use this last function to predict whether today the crash is going to happen or not, or tomorrow the crash is going to happen or not. And actually, we are using it whenever we run our infinite while loop, and we are going to, for example, monitor the market 24-hour a day and 7 days a week, and it will be run in our infinite while loop. Okay, I just press Shift and Enter, and I just want to have this data frame again, but instead of just defining it here in this cell, I want to use this function to get the data. So I say S&P 500 is equal to get the stock data, and I give the ticker name. The ticker name was here written like that, and start and end date. The start date is equal to our start date variable, and end date is equal to our end date variable. I want to have this data frame again. I call it here again. We have the same data frame that we had here before, but in this case, I use this function to get the data. Now I want to add the technical indicators and crash label to this data frame. To do so, again, I say this one is equal to add technical indicators, and here I just want to add it to our S&P 500 data frame. If I press Shift and Enter, I can see that single moving average, 50, 200 RSI, and volatility are added to our data. And along with that, I want to use this function to add the crash label too. So again, I say S&P 500 data frame equal to label crash, and here our data frame, which is this S&P 500 data frame. And I don't change the threshold. I don't give any threshold to our initial threshold, and I leave it to be like that. If I press Shift and Enter, then another column named crash is added, and it is 0 and 1. When it is 1, it means that the changes in comparison with previous day, the changes in close price in comparison with yesterday days is more than minus this value, this threshold. So that's why this one is 1. Here is 1, 2, because we exceeded the threshold downside. And I add a variable named latest day. I say it's equal to this SP 500, this one, and I use ILOC to have access to the last day data. This one, -1 means go and take the last day data. In this case, it would be the last row, 13th December 2022. It takes this one. I can just, if we, instead of this data frame, I just ask for latest day. It will return as the latest day here like that. You can see that the latest row is returned for us. Okay. Okay, now I just comment this latest date, and I want to have my S&P 500 to have some overview about it. Then I add this other part of the code. I already wrote it. I paste it here only. We have our X's and Y's. These are our features, and this one is our target. We wanna use these X's here, or this feature, to predict our label, which is the crash label here in this case. I believe that open, single moving average 50, single moving average 200, RSI, and volatility can be important if you think there are other criteria that we can predict the crash based on them better. I would highly recommend you to do it by yourself and add it and test it. So this is our Y's, and now we split our data to X-train, X-test, and Y-train and Y-test. And to do so, we use train, test, split method, which we just imported here from the scikit-learn model selection import train test split. This is a method in the scikit-learn. We use it to split our data. We say train test split. We give our X's to that and Y to that, and we say test size is 0.3. It means 30% of our data, this 3073 rows, 30% of them are test data, and 70% of them are train data. So X train size and Y train size should be 70% of this 3073 rows, and X test size and Y test size should be 30% of this value here. And we use random state 42 to control randomness and reproducibility. It means if you use the random state 42, you would see the same result that I am seeing here right now. Okay, you can see 40 or 102. But as long as we are using the same random state number, you should have the same result as what I have here, okay? And then after splitting data, we feed our model. We say model is equal random forest classifier and estimator is equal to 100 and random stays 100. This one is just for reproducibility and control the randomness, but actually here it's where we can tune our hyperparameter. One of these hyperparameter is an estimator. We can use it to reach the different performance of this model. But if I press Shift and Tab here, I can see that it has n job, random state, verbose, class weight, alpha, and max sample. These are our hyperparameters that we can change them. By changing them, we have the descriptions for all of them here. I recommend you go through and read them. But by changing them, we can make our model work better. And then after defining our model, we can feed our model. Okay. To do so, we just say model or feed or train. But this is the command in scikit-learn to train the model, which is feed. And we want to feed it or train it by our x-train, y-train data. Okay? I press Shift and Enter. It takes some time, but at the end, we have a model named random forest classifier. And I just say we can save it even here, but it's already there. Model, now it is fed. Now our model is ready. I want to see the model is trained based on X train and Y train, and it has found some patterns between the X train and Y trains. And now we want to use it to predict our test model. Okay, we say Y pred as prediction is equal to model dot predict, and I want to predict X test and Y pred return me Y pred 2. I press Shift and Enter. It returns me this area, and we can see that it's 0, 1. When it is 0, it means we have not exceeded the threshold downside, but when it is 1, it means we have exceeded the threshold downside. This is what we predict, but we have Y test here. This is not the prediction anymore. The Y test is reality. This is what, just let's comment it. Y test is what we really have. This is what we really have, but ypred is what the model predicted, okay? In the best case, this ypred would be 100% the same with this test. It means our model had predicted everything correctly, but this is very rare, and no models can be that much perfect. And actually, when it is that much perfect, we should be suspicious that something is not correct. So now we compare this ypred, the result that our model predict, and y-test, which is the reality, and we want to see how accurate we are. I comment them like that and press Shift and Enter. And now I use another part of the code that I have already written here. It says accuracy is accuracy score. This is again the method that we imported here, accuracy score. And we say accuracy is equal accuracy score between y-test and ypred, and then print as the model accuracy is equal to accuracy multiplied by 100 and only to 2-digit, and based on the percent, so it will return as the percentage. And then we print the n classification report, print the classification report between, again, y-test and ypred. If I press Shift and Enter, it will tell us the accuracy is 61.06%, and here is the precision. Let's try to make it better. For example, I change this n estimator as a hyperparameter to 50 to see what is the performance. Is it going to be better or not? If I press Shift and Enter, okay, now I see that the accuracy is 73, almost 74%. It means 74% of the time it predicts correctly, and it can tell us whether the price decreases more than the threshold or not. The precision is for the 0, the precision is 77%, but the precision for predicting whether we exceed or not is 58%. It means when it says we are not going to exceed 77% of the time, it predicts correctly. But when it predicts that we exceed the threshold, 58% of the time, it predicts correctly. And we can even use the matplotlib to plot this result here. I just paste the part of the code that I already wrote. We say, okay, we have a prediction. We have a prediction column. It's called model.predict x. And then we used our figure to have the fixed size, and then we plot S&P 500 index and the close. If I just run this part, it would be something like that. And then we add scatter for our crashes, the real one, actual crashes that actually happened, and this is the prediction crashes. And we press Shift and Enter, we can see them here. It says this one is the actual crash, and the circle one is the prediction crash. We can zoom in and zoom out to see it too. Here it tries to predict a lot. That's because this threshold is very small. If I increase it, actually, I can see that the data changes and it tries to predict less. See, it's less. But in this case, the prediction is 99%, but it's somehow suspicious. Why? Because actually, if we go inside the code, and for example, for this, if I, for example, say, okay, SP 500 and choose the crash column and say, okay, that value counts like that. I press Shift and Enter, we can see that 3035 times it's 0 and only 38 times it's 1. So basically, if it says 0, it's high likely that it predicts it correctly because our data is imbalance. We don't have enough data for the crash section. That's why I decreased the threshold so it would be more realistic and we would have more data for the crash side. In this case, for example, we would have 2210 times it doesn't have crash, but 863 times we would have crash. So the data are more balanced and we have enough data for both sides. So now we saw the performance of our data, and in the next video we will learn how we can run this data once per day at the beginning of market open and to predict whether this day we would have a crash or not. How likely is it to have a crash? And then based on that we can have a logic to open or close an order based on the API of our broker. I hope you enjoyed this video. Please do not forget to hit the like button, and I will leave you the code in our Telegram channel, which you can find it in the descriptions. Have a good day. Goodbye.